All right, number 9, find the area of the triangle. So you guys, for this one, remember the area of a triangle, okay, is 1/2 times side 1 times side 2 times the sine of the included angle. This is just to plug in, make sure that you know it, okay? So if I plug that into my calculator, it's 0.5 times 35 times the sine of 27, and that equals 7.94 or something like that. Don't miss that question, please. All right, remember you guys, for number 10, I said don't worry about the airplane bearings, okay? But let's look at number 11. So it says from a certain distance, and you guys, I did this one with you in class, so I'm going to do it again, but really you should have this answer already. So the angle of elevation to the top of the building is 17 degrees. So you have a building, okay, you're standing here looking up at the building, so this is the ground. So if you're looking up this way, so it's saying that this right here is 17 degrees. Then it says if you move 50 feet closer, so maybe somewhere right there, so this is 50, you move 50 feet closer, and you look up at the building again, your angle of elevation is now 31 degrees. And the question is find the approximate height of the building. I'm going to call that big H, okay? So you guys, the first thing you want to do is get all your angles in there. So if this is 90, okay, then in this small little triangle with the 31, this right here is just going to be 90 minus 31. So 90 minus 31 is 59 degrees. All right, 90 minus 30 is 60, 60 minus 1 is 59. Okay, to find this angle right here, we're just going to subtract 180 minus 31. Here, I'll put 90 minus 31 over here so you know how I got it. Okay, this guy's going to be 180 minus 31. Well, 180 minus 30 is 150, minus 1 is 149. And then you guys, this one right here, I'm just going to subtract both of them from 180. So 180 minus 149 minus 17. I think it was 14, but I don't remember. 180 minus 149 minus 17. I got 14 degrees. Okay, so step 1, find all your angles. Okay, now the next thing you want to do is you want to find this side right here. Okay, so I can use that triangle right here, the oblique one. I can use this guy and law of sines to find it. That's not what I wanted. Try this again, sorry. So check this out. I'm just redrawing that oblique triangle. This is 50, this is 17, this is 14, this is 149, and I'm looking for this, right? Okay, so I can use law of sines on this. So I'm going to go ahead and go sine of 17 all over, opposite of 17 is this, so I'll call it x, over x, equals sine of 14 over its opposite side, which is 50. So if I cross multiply and divide, I'm going to get x equals 50 times the sine of 17 all over the sine of 14. I'm plugging that in, so I have 50 sine of 17 divided by the sine of 14, and that gave me about 60.4. So x is 60.4. Okay, so if this guy is 60.4, that's this one right here, 60.4. Now I'm going to look at the right triangle. So let me redraw this one more time. This is the right triangle. Remember, you guys, the blue highlighted line was this one. I just found that one. That was 60.4. But now I know this is a 90. I know this is 31 and this is 59. And I'm looking for the height. So pick one of these angles. It doesn't really matter. Let's say you pick 31, okay? I can use opposite over hypotenuse to find it. Remember, opposite over hypotenuse, that's SOHCAHTOA, so it's sine. So I'm going to say sine of 31 is opposite over hypotenuse. And then to solve for the hypotenuse, I'm just going to multiply by 60.4 on both sides. So it's 60.4 times the sine of 31. And we got 31.1. So the height of this building is 31.1, what is it, feet, meters, whatever. Is that okay? All right, let's look at 12. Maddie's standing on a cliff looking at a boat. We did this one in class together as well. So you guys, here's the cliff, here's the water, here's the boat, right? So Maddie is standing on top of this cliff looking at the boat at an angle of depression of 20 degrees. So if she's looking straight out, angle of depression is looking down from that, right? So this right here is your 20 degrees. So she's looking down at this boat at 20 degrees, something like that, right? So this is the triangle that's being made. Sorry, I should have made a little bit better. This you can assume is a 90 unless it says otherwise. And it says the cliff is 250 feet high. How far is the boat from the base of the cliff? So boat, base of the cliff. So we're looking for X. Okay, I need to get that angle inside the triangle somehow. If this one's 20, well then this one has to be 70 because that's a 90-degree angle. So now that I have enough information, let's go ahead and do it. Okay, check this out. I have an angle. I have opposite over adjacent. Opposite over adjacent is tangent, so I could say the tangent of 70 is opposite over adjacent. Multiply both sides by 250. And I'm going to get 250 tangent of 70. And that is going to be 686.9 or something like that. And it's in feet. Okay. All right, let's do number 13. And then you guys, I'll do another video for the last part. So Violet and Harold, these are my dogs. Harold's the one that passed away. Poor boy. Okay, but anyways, okay, so we've got this compass here. We got north, south, east, and west, right? Okay, it says Violet runs at 15 miles per hour going 20 degrees east of north. So I need to figure out where this is. So I'm going to highlight the second part, the north, highlight the north. If I want to go 20 degrees east of that, I'm going to the right direction. So I'm going 20 degrees east. So this right here is Violet. Okay. And you guys, she is running at 15 miles an hour for 2 hours. So 15 times 2, her distance is going to be 30. So I can label this right here 30. Okay. Now let's check out Harold. Harold runs at 10 miles an hour going 35 degrees east of south. So again, I'm going to highlight south, the second heading, right? Highlight south. And then this one is saying that I want to go 35 degrees east of that. So again, east is to the right of that. So 35 degrees east, something like that. So this is Harold running. Okay, and you guys, this is 35 degrees. Harold runs at 10 miles an hour. So 10 miles an hour for 2 hours. So times 2 is going to give me 20. So I can label this green thing 20. Okay, and now the question is, how far apart will they be? Okay, so I'm looking for this. So let's redraw this again. I know that this is 30, this right here is 20. And you guys, the angles, they are not actually in my triangle. So I need to find this angle right here. But I know that all 3 of these add up to 180. So to find this angle right here, I'm going to go 180 minus 20 minus 35. Okay, so if I do 180 minus 20 minus 35, I could have done that in my head. It's 125 degrees. And I'm looking for this. Okay, so I can just use law of cosines. Label this triangle ABC. Right, I can call this little b if I want to. Okay, since I'm looking for a little b, I want to start with little b squared. So little b squared equals 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of angle B, which is 125. Law of cosines, right, guys? Okay, so if I'm looking for B, just take the square root of it. Take the square root. And plugging that in, I'm going to get second square root of 20 squared plus 30 squared. Is it 30? Yeah. Plus 30 squared minus 2 times 20 times 30 times the cosine of 125. And I got 44.6. And I think is there units on this? Miles. Okay. All right, let me stop the video. I'll make another one for the last part.